David, Leah, welcome, and thank you so much for joining me today. So today we'll be talking about cataclysms, cyclical cataclysms, and I want to start with what these are because cyclical cataclysms, it's not something that comes up at school, nor did it come up when I was at uni, and it's not something that we talk about at family dinners or with my colleagues. And for a lot of people, it's a new concept. What is it? What is cyclical cataclysms?
Well, I could chime in first. If in mythology, it's not a mystery. If we look in all the ancient texts, they talk about fire and brimstone and all types of cataclysms. A good friend of ours, Robert Felix, who wrote the book on mass extinction and magnetic excursions, God rest his soul, he alluded to the fact that mythology is not explaining it correctly because they didn't have the scientific background to understand what was happening. All they could explain was what they were seeing: fire in the sky, massive floods, or however they described it. But as we advanced with scientific technology and papers and study and peer-reviewed research, we can kind of hone it down to a few things. The most recent catastrophe, which amazingly enough, for the last 2 decades, it's been heavily studied with dozens of peer-reviewed papers, is the Younger Dryas event, 12,800 years ago. Now, that event is still a mystery to many scientists, although the data is in. We've got all these cosmogenic nucleotides. We've got all these cosmogenic types of particles being found exactly at that stratigraphic layer 12,800 years ago, which all allude to cometary impact or something celestial in the form of an array of comets coming in to the inner solar system and affecting Earth. We've also got the Carolina Bays. These are millions of impact structures on the eastern US, which are also associated at the same time. So, and also at the same time, we've got the mass extinction of 65% of all megafauna on Earth. So the reason there's no big animals in North America is they were all wiped out at this moment. Africa wasn't affected, which is why we still have giant things like giraffes and elephants. Those were all over here in North America. We had 4 species of elephant in North America that all disappeared 12,800 years ago. So because now we have scientific data on this event, this may be the event in antiquity that all these traditions are speaking of, because it's just not that far back. It is also the time of the destruction of Atlantis, which is also in mythology. It all gets dated back exactly to around this time. Now, Atlantis is a little different because it's actually being dated at the end of the Younger Dryas event, 11,700 years ago. So we actually have 2 catastrophes now to contend with. The one that killed all the megafauna 12,800 years ago, called the Younger Dryas event, and the end of the Younger Dryas, which, if you look at a graph, shows sea level rising hundreds of feet to its current level in maybe just a few decades. And that event was 11,700 years ago, which is associated with the flooding of Atlantis. So if sea level did rise hundreds of feet in a short period of time, and there was an island nation in the middle of the Atlantic, well, you could put 1 and 2 together. So these are the 2 major catastrophes. Now, they're not the only ones. My partner and I have been studying catastrophes for a decade here. And we can even associate things like major impacts in the Australian Ocean with the flood of Noah 5,400 years ago. So what we've come to conclude is that at any moment, humanity is due for the next catastrophic reset.
Part of the reason that we don't get the narrative of catastrophism, which I will contend, I think there is some cyclicity, but I don't think it's all cyclical, in the sense that some events do not happen on a schedule. They're more random than that. But the reason that we don't hear about catastrophism typically is because the current academic narrative is uniformitarianism. Things are as they have largely always been, at least for this geological era. That's been the reigning narrative for quite some time. And every time there's it's very hard for paradigm shift to happen in the scientific community. It takes a lot of time to shift the perspective within the scientific community, because you've got a bunch of scientists whose whole entire careers are based on a particular narrative. And so it's very hard to shift that. So we're still kind of dealing with uniformitarianism, when it seems that in reality, Earth does go through catastrophes over and over and over and over again. And we have witnessed this as humans, but certainly not in the modern era, and not in the last 5,000 years or 12,000 years. So it's hard to break through with that. I mean, I know Diamond saw a lot of this in his graduate geological studies. He's looking at the rock record and looking at the stratigraphy and seeing that there is cyclicity in the rock record, and yet running into resistance in the academic community about that all the time.
Why do you think that is? Is it just because they are stuck with one narrative and they don't want to sort of how to say, they don't want to risk their careers and reputations? Or do you think
Yes.
it's something that's going to happen imminently and they
No.
would rather not speak about it?
Well, there is that. World governments, people controlling the narrative, they're obviously not going to announce any eventual catastrophe coming that's going to kill half of the population. People would quit their jobs. They would start preparing. They would start learning how to grow food. They would start
panicking
or panic and jump off buildings. But it's interesting because I really didn't think it was going to be like this. I jumped into science with an open mind and just was so enamored with the field of geology, stratigraphy, and paleontology. I just jumped in. I was like so fascinated by all these things. And when I would present at GSA meetings, because I'm only presenting on cyclical catastrophes that are depositing rocks, a nested hierarchy that we were using the Milankovitch cycles. So what we were saying was there's a 100,000-year catastrophe, a 26,000-year regular cycle that is pulsing off. And mythology also corroborates this. We've got the Yuga cycle, which is some of the oldest spiritual doctrine on Earth coming out of the Far East, which corroborates a 26,000-year cycle, the precession of the equinoxes. But if you just go look at it in the rock record, it shows cycles of catastrophe being deposited in 26,000-year packages, which is represented by major eustatic changes, which is a big word. It just means sea level changes. So every 26,000 years in the rock record, the ocean goes up and down hundreds of feet, inundating everyone living on the coast and then, exposing them. So something is controlling this. And this cycle continues even when there's no ice on Earth. This is how little we know about what's driving this cycle. It's easily explained with ice caps building and sea level dropping, then ice melts and sea level rises. But this cycle continues even during geologic times when there's supposedly no ice on Earth. So we don't know nothing about nothing. But what we do know is that mass extinctions happen every few 100 million years. And on smaller scales, we have minor mass extinctions. The last mass extinction just happened 12,800 years ago, and no one is taught this at all in grade school. This should be like the most important event that ever occurred in recent history.
To answer your question a little bit more, so my background is in philosophy of science, and there's a very important book that was written by Thomas Kuhn, Kuhn, called The Structure of Scientific Revolutions. And essentially what he showed in this book is how difficult it is for a paradigm shift to happen in the scientific community. So it's not just, in the field of geology and earth sciences, it's in biology, it's in even medicine, it's everything, where you get this tremendous resistance to changing the perspective and the framework for any particular topic. And I think it does have quite a lot to do with scientists who are worried about risking their entire careers with a new theory that kind of blows everything out of the water. Because what often happens when a scientist comes up with a new theory that doesn't fit the current narrative, they are vilified, they're shamed, their careers may end up on the toilet, they may not be able to get any funding. It's a very, very risky thing to do as an academic. And incidentally, many years ago, I worked for an organization that was doing a historical anniversary project on another organization called the Gordon Research Conferences, which had a style and a style and a representation, a reputation, excuse me, that was different than all of their conferences. So what they would do is they would have week-long conferences on a particular topic. Everything was off the record. And you were also in a kind of like a more vacation environment, where you could relax with your colleagues. So this allowed scientists to bring up their wackiest ideas and chew them out with their colleagues without fear of their careers ending up in the trash. And as a result, there's a very long and strong history of innovative and massive breakthroughs happening because of these conferences. So, I mean, there really is a problem as far as that resistance goes within the scientific community, and it takes quite a lot for things to change over and shift.
Well,
so the result is that we get a lot of stuff in our textbooks that are really not up to date.
Yeah, that's the initial problem. That problem has been going on for a century.
Yeah.
That there is resistance to change in the scientific community, but it's gotten much worse in the last 2 or 3 decades. It's now become political. So you add a political layer, and the only way you can get funding is if somewhere in your proposal you put climate change. That's the only way you get federal funding. And none of the studies that people want to do have anything to do with climate change. Everyone knows that climate changes. It's changed for millennia, millions of years. Like, I want to study seals or penguins, or I want to study catastrophes or impacts. You can't do it unless climate change somehow is involved. Or the only place, back when I was getting funding, the only place I could get money was from the state. And it's a few $1,000s a year. So you basically can go out and do field work for like 7 days. And that's the problem. Like, Leah and I are listed as one of the top 100 most dangerous disinformation specialists in the world, according to an NGO that used AI to scrub the internet because of what we say. Because what we say is opposite of the narrative that they want to portray. We get targeted. People claim we're like funded by big oil and stuff like this. I make $800 a month on internet revenue. I have a farm here. I live in the dirt. I sleep in a trailer. People are insane.
Wait, so what exactly are you saying that puts you in this list?
Who is it? The Center for Countering Digital Hate?
We discuss quite frequently it's not just a matter of belief, but based on information, the hoax that is the global warming hoax. We discuss this quite frequently, and we make it clear why, based on the geological data from the past, that this is nonsense, that anthropogenic global warming is not a thing. So there's this dark money NGO called the Center for Countering Digital Hate. And 2 years ago,
funded by USAID, thankfully that's now defunded.
Right. This is dark money stuff, right? So, and it's a weird organization because they don't even list their researchers. And then they take their results and they give it to companies like Google and say, these are the people that you should censor. Like, this is partially how some of the censorship that occurs on YouTube, for example, happens, is through stuff like this, is pressure from these big dark money corporations. So what they did is they used like an AI to look through a bunch of YouTube channels, had the AI run their algorithms to pick up people that they will say are, climate change deniers, And it's hilarious to look at this report that they put together 2 years ago. So they showcased us. And then, for example, I don't know if you're familiar with Tony Heller, who has done a wonderful job collecting just basic information and data from decades past, showing why this narrative is false, just simply by even looking at newspaper records about, how hot it was, let's say, in the United States in the 1930s, when it was quite hot. Anyway, they showcased him as well, and I was cracking up because he had they screenshotted one of his videos, showing a data graph that proved the point that he was making and claimed that he was lying while showing the data that proves that he's correct. So there's so much like political pressure on a global scale to censor scientific information that is true and real from the general public. It's really crazy. And it tells you how big this push to censor certain information really is.
I mean, if AI is helping to censor, it made their job easier. It's just like
Right.
scour the internet, find the people. Wow, it's ridiculous. But
well, and just as a sort of a side note, it kind of brings up how scary AI really is, right? Because the tendency is going to be to treat AI as if it's smarter than us and the arbiter of all truth. But it is not. It is based initially on programming from human beings. And so it's very easy to instruct an AI that says, global warming is the absolute truth, pick out all this, you know what I'm saying? Like, it's very dangerous, I think, to humanity to treat treat truth that way.
Absolutely. Yeah. Do you think that I also heard this theory that obviously this climate hoax is, I think there's a lot about money laundering, reallocating taxpayer money, because how else can you do that? But also another thing was that the earth is warming mainly because of, I think the idea was the sun, the solar events, and then how it heats up the earth. um and then they didn't want us to know why it actually happens, and that's why they came up with the global warming. Do you think that could be the reason?
Well, I mean, yes, because again, if you look at the data that we have and the proxy data that we have, let's say estimating Earth's temperature over thousands of years, there is a very specific cycle of temperatures going up and dropping off, and going up and dropping off, and going up and dropping off. This has happened again and again and again and again. What we're experiencing right now is part of that cycle. This is, of course, not taught in school. This is information that will be censored, and it does seem as though part of it's like a grift, like you said, in order to draw all of the remaining wealth out of the public by imposing restrictions on their lives, by making their cost of living higher, citing the danger to humanity, which it's kind of mind-blowing, but it has worked thus far. And the amount of money that has been generated simply out of quote unquote green technologies, which frankly are not any more environmentally friendly than anything that we've been doing. The environmental cost of lithium batteries and mining metals like cadmium that are required to make these batteries, and to make solar panels, we still need oil and gas to make solar panels. There's humanitarian crises in other countries as far as mining things like cadmium goes, because we have young children in other countries mining for these materials. And the amount of wealth that has been extracted out of developing those technologies is huge. And it's not any more environmentally friendly than anything we've been doing.
Yeah, it's actually much worse. And if you didn't know, in the late 70s, the Club of Rome made a decision on what the next control narrative was going to be. The Club of Rome is the group of elite bankers that decide what's happening on Earth. It's now referred to as the IMF, and you know, the WEF. These are all these elite groups of controllers. And in the late 70s, they decided that global warming was going to be the next narrative, and they stuck with it. They had to change it to climate change when global warming leveled off for 11 years in the early 2000s. There was no warming. And then they got an El Nino, which spiked the temperature another degree. And they were like, oh, it's back. Now it's climate catastrophe. So they went full, you know, all in. The problem is that these cycles reverse, and they're controlled by the sun. So we were initially jumped into this talking about catastrophes. These catastrophes that happen on Earth are scalable. The one that happened 12,800 years ago, if that happened today, everyone dies except for a few percent of the people, some of them that were in caves, some of them were hiding under the right rock, and it's a complete rebuild. But since then, we've had hundreds of resets in the last 12,000 years. Every 1,000 years or so is a bond cycle, which is another solar cycle, which is a huge solar outburst and then a huge solar quieting. It lasts for, it takes a long time for these to happen. And there's also some deep grand minimas. Grand minimas is when the sun has not active at all, and rivers and complete growing areas freeze over and everyone starves. These happen every 1,000 years, which is why if I can pull up some graphs, we don't have to. I have graphs on my social media you can look at in the last 5,000 years of temperature, where you can see the Minoan warm was warmer than today. And then a series of volcanic eruptions happened and the solar activity dropped off and the temperature dropped several degrees C and the empire failed. The Minoans disappeared. And then 1,000 years later was the Roman warm, and we've got the Roman Empire and everyone flourishing. And then a series of volcanic eruptions and a quiet sun dropped us off into the dark ages. This is the medieval cold and what people refer to as the mini ice age. These cycles happen every 1,000 years. And when it's warm today, the last 1,000 years, we've got the modern warm. It's warm. We've got civilization flourishing. But every time that happens in a very short period of time, the empire ends globally. The whole world collapses. People starve. The plague is in, you know, there's disease, there's pestilence, there's starvation. And then it gets warm again. And then we have another empire. So we are at the end of peak modern empire, which is literally idiocracy. We're at peak stupidity. We've polluted the whole planet. We developed chemicals that are called forever, that have polluted all air, water, and wind. We need this reset because we need to start fresh, because we certainly aren't going in the right direction here.
So I think I understood what happens every 1,000 years. What causes the big one, which happened 12,800 years ago?
Well, let's back up on the, can we back up on the solar science a little bit? Just because, from the beginning, you know, we have an 11-year solar cycle where we have a minimum and a maximum solar activity and minimum solar activity, which corresponds with sunspots. But outside of that 11-year cycle, we have larger cycles where the maximums are larger and the minimums are smaller. So what that is sort of what leads us to grand minimums, where we have an extended period of solar cycles where the minimums are extremely low and there's very low solar activity. And that corresponds very well with the temperature on Earth. So that's sort of how we get to that 1,000-year cycle currently is within that.
Yeah, that's just a small cycle. If you think of the sun as some sort of device that is a heater, right? You can buy all different kind of heaters for your house. You can turn them up, you can turn them down. But when we look at the sun and we look at solar physics, our sun is referred to as a variable star. What does that mean to anyone? It means that it changes. It's variable. It gets hotter and colder. Its intensity is changing like a pulse.
Yes. Mm-hmm.
Right. And so with global warming science, right, the climate science they use, our sun is considered a constant. It's not variable. It never changes. So in all of their models, the sun is constant, which is completely insane. You know that if a cloud moves in front of the sun, the temperature drops 10 degrees while you're standing there instantly. And when the sun sets, the temperature here drops 30 degrees every night. So clearly the sun is controlling the temperature on Earth. And because it's variable, it seems to have a 1,000-year pulse where it gets hotter and colder. Now, the graph that that I had up that you took down, that's the Epoca ice core data, which comes from Antarctica. It is the longest continuous climate record we have, which they just now found an additional 400,000 years, which they are drilling now, which will extend this graph all the way back to 1.4 million years, which will mean that we have a 1.4 million year high resolution climate graph. And you can see on here, these ups and downs occur every 100,000 years. The last major up, which brings us to the modern day warm, is that sinking of Atlantis event 11,700 years ago, whatever that is. So whatever these events are every 100,000 years, you can see they occur at the same amplitude again and again and again. At least for the last 400,000, they're pretty much very similar cycles. Prior to that, they're a little weaker and maybe longer or double cycles. But in the last 400,000 years, we've had this 100,000-year catastrophe that no one can explain, where sea level suddenly rises 400 feet and it gets warm and we prosper. Then after a few tens of thousands of years, we go back into ice age and we all go back into caves and just try to survive. I mean, and we're about to go back down. We've been warm now for 12,000 years. The longest these interstadials last is 20. So within 8,000 years, we are going to be back in an ice age.
And what exactly why is there a difference between this big events and the small events?
Well, some postulate it has to do with celestial mechanics. So it could be in the Milankovitch cycles that were first explained in the 1940s. We have a cycle called eccentricity, where the ellipticity of our orbit gets thinner and wider and fatter in a 100,000-year cycle. The only problem with using this to explain that abrupt cycle is that it's not abrupt. The change is gradual over 100,000 years, where our orbit gets fatter and thinner. There is no trigger. And so geologists coined a term, the tipping point, which means nothing. It's a way to explain something you can't explain. So they invented tipping point, and we have no idea what that means. It means we don't know what they're talking about. So something is happening to our planet we are unaware of on a 100,000-year cycle. And that's the truest thing any scientist has ever said. We don't know what it is. We explain it using words that don't mean anything, but we don't know what the 100,000-year cycle is. The last one just caused a mass extinction. You know, all of North America's megafauna died. We almost didn't make it as humans. You know, very small factions lived. Most of the people made it were in Europe and Africa. Most of the people in North America didn't make it. Very small groups made it here. Because maybe the event was centered on North America. That's the only thing we can conclude. But we don't know what the event was. We know that the Younger Dryas event was a comet impact, but a comet can't come and impact us every 100,000 years. That makes no sense. So whatever the event is that's causing this may also bring comets in. So that is a piece of evidence we have. Cometary impacts, which cause mass extinctions, occur because of this event. But what is the event? We just
I think that's been the biggest mystery for Diamond and I, is trying to understand and pinpoint exactly what causes this kind of cyclicity, you know, and you know, there are other phenomena which some have postulated are on a cyclical basis, like, for example, magnetic excursions and reversals, but the data does not show a regular cycle for excursions and reversals. It shows it to be quite random, actually. But those events are also mass extinction events, because in either case, we end up with a period of time where the magnetic field on Earth is extremely weak. And when that happens, we are barely protected from cosmic radiation. And so that in and of itself, and Diamond mentioned earlier, Felix, help me out, Diamond.
Robert Felix?
Thank you, Robert Felix.
Magnetic Excursions and Evolutionary Leaps is his book.
This is an excellent book that he wrote linking mass extinctions with magnetic reversals, which makes quite a lot of sense because it would dramatically change the conditions on Earth for a period of time. And in fact, there's really good evidence, showing let's say a correspondence, I should say, between the extinction of the Neanderthals about 41,000 years ago. We were in the middle of a major, it's the Leah Shaper. Is it a reversal or an excursion, Diamond? I can't remember.
It is an excursion because it came back, but during the Leah Shaper excursion, we reversed for at least 100 or more years, but the field flipped back to regular polarity, so it's referred to as an excursion. But we reduced our field strength to almost 5%, almost zero. If it gets to zero, it's like we're in space. I mean, it's that bad. So at that low field strength, like the ozone will be destroyed, UVA, UVB radiation. If you were to go outside when the sun was up, you would instantly get skin cancer in like 6 minutes, which explains why at that time we've got all these cave paintings that all of a sudden showed up on Earth 42,000 years ago. The only people alive were hiding in caves. They had nothing to do. They couldn't go out during the day. They're starving, and they created jewelry and art. That's how that happened. It wasn't because we were smarter or something. It was by necessity. Prior to that, we were out hunting all day, enjoying the Earth. Then we all started dying being outside, so we had to go into caves during the Leah Shaper excursion. This is during that time when all those wonderful cave art in Europe is made. And unfortunately, we're going back into another excursion right now.
So then there's a certain pattern where the magnetic field of our planet becomes weak, and then it strengthens, becomes weaker and strengthens. And whenever it becomes weaker, these events are happening. Can you explain how that works?
Well, I mean, that seems to be something of a mystery to some degree as well. I think to us, it seems quite clear that it is a connection. It does have to do with our sun again. So we're working within a framework of the electric universe theory, which postulates that everything in the universe works as electromagnetics. This is not a mainstream perspective at all. But it does help explain many physical phenomena that are otherwise hard to explain. And so, the sun has a magnetic field that changes, again, with the solar cycle. In response, our magnetic field changes. So when we're getting bombarded with a lot of cosmic radiation or solar radiation, really cosmic rays from the sun, when we're getting bombarded with a lot of that, it actually strengthens our magnetic field. And when we're not, our field gets weak.
You misspoke there, Leah.
Please go ahead.
When the sun is at solar max, every 11 years we have a cycle. There's a max and a minimum. We are just coming off a solar max for cycle 25. What do you know has been happening? Geomagnetic storms. We had the Mother's Day superstorm last year when we just had another X flare. So during solar max, we've got these major flares that are pointed at Earth. Those events are what strengthen the magnetic field. And by having a strong magnetic field, we can prevent cosmic rays from entering to Earth. When those storms diminish and the sun goes quiet, the magnetic field shrinks on our planet. The magnetosphere shrinks because it's not protecting from anything. When it's protecting, it's growing. When nothing's happening, it's shrinking, and all these cosmic particles can rain down on Earth. And that is when bad things happen. So the quieter the sun for the longer it is, the worse it is for humanity because of the cosmic rays. Cosmic rays do one thing that we know of. They're the only thing we know can mutate cells, change cells. Cosmic rays are the only thing that do it. And we know they do it. And so during these magnetic excursions, when the sun is weak and the magnetic field shrinks, we are bombarded by cosmic rays. which are bad for biology, high UV radiation. So all the plants and animals die that are vulnerable. But at the same time, there are ones that are alive that are being mutated and changing to adjust to these conditions. And right at that boundary, everything dies, but right on the other side, everything's new. So they are destroyers and creators at the same time, these magnetic excursions. They kill everything that's vulnerable, and they mutate everything that's making it into new, better versions. So it's a catch-22. It is the cycle of evolution.
But what is kind of vexing on this topic is that there is no pattern. There is no schedule for this. So it's been very hard to sort of tease out why we go into excursions and reversals when we do. I think Diamond might have a graph that shows all of the times that we've been in excursion or reversal. And it's not very clear, sort of what triggers an excursion or a reversal. We understand the basic dynamics, let's say, between cosmic rays and our magnetic field, but as far as the larger pattern as to when we go into full-on excursion or reversal, it's really not clear.
Yeah, so the yellow lines on this graph, Louisa, are what are scientifically accepted magnetic excursions, the yellow vertical lines. You've got the the MD is the first one. That is a Younger Dryas event excursion. And then you've got the Mono Lake, which is like 34,000 years ago. And then the real deep one here that we're discussing is the Lechamp, which is 41.5. And then you got the Blake, the Iceland, the Pringle Falls. You can see there's no periodicity to these. Sometimes they're grouped together. Sometimes they're far apart, but they happen haphazardly. And if you try to match this with like a temperature graph or the Epica data or anything like that, you can't get any correlation to anything. So it's like the ice core is showing us the temperature, very high resolution, but that has nothing to do with the magnetic field. So the magnetic field really doesn't control climate, but it controls mass extinction and speciation, which is counterintuitive. You would think like the climate would control who lives and dies, but it's not. It's how much cosmic radiation enters Earth is controlling our evolution. And think about it. It makes sense. Humans have been around for 200,000. Humans just like us, at least 200,000 years. I would say 350, and some people might call me on that. But humans just like us, Homo sapiens sapien, go back at least 200,000 years. In that time frame, we've had two major ice ages where we've had glacial maximum just 28,000 years ago, which is the coldest time on Earth ever in 500 million years. And we lived. So clearly the climate is not what kills animals and people.
It certainly makes living harder, but we make it.
Just go into caves and eat different stuff.
So now we have data that the magnetic field is weakening. And is that true that they stopped publishing them, making it available for everyone? That's what I heard, that they used to be open to public. Anybody could see them, but now they're not available.
The World Magnetic Model about 15 years ago was updated regularly. Then they began updating it every 5 years. And this coincided at the same time when the magnetic field was kind of exponentially decreasing in strength. And at the same time, it was the North Pole was accelerating its movement to over 50 miles a month. And so they were like, we can't let this out. So they were going to update it every 5 years because they would have to for navigation and for runways, for planes, because they're using gyroscopes and compasses. And so that worked well for 2000, 2005, and 2010. But when 2015 update came, they had to update it in 2014 because the field was shifting too rapidly. And then again, the 2020 update, the North Pole had moved so much, they had to update it in 2019 before the 5-year update because the North Magnetic Pole had moved so much. Pilots they didn't know where they were landing. Ships were, showing up 100 miles off course. And so it really didn't work hiding it from the public, because it revealed how fast the North Pole was moving, because they had to update it early and then explain themselves. And
well, you can also, you can, to some degree, you can get away with this because a lot of navigation these days is done by GPS rather than using, you know, the actual magnetic field to navigate. I mean, we still use that, so it does present problems, but on some level, you can get away with not updating it as often as it should be updated for safety reasons.
But you do have that graph, don't you? The magnetic field, the updated one?
Currently, I imagine that Diamond does have that, and it does. It is, the magnetic field strength is decreasing exponentially. Which,
well, and the last world magnetic model update also showed that the North Pole has slowed down quite a bit, so it's not moving as fast as it was in the last decade, but it is still moving rapidly. 30 miles a month instead of 50. So and that makes sense because it's never moved at the same rate ever. It goes fast, it goes slow.
But what does that mean for us? That the magnetic pole is moving, but what does that mean?
It probably means, because of the speed it's moved thousands of miles in the last 100 years. And prior to that, it's maintained the same position for thousands of years. So all of a sudden, in 1859, after the Carrington event, which is the largest solar storm we know of in our history, for some reason, that event, when it hit Earth, instead of the pole sitting where it was over Canada for thousands of years, at the Carrington event, it started to move rapidly towards Siberia in a straight line. And if you keep moving that straight line, that takes you right around the globe to the equator, where the South Pole is moving, and both of the poles will meet in Indonesia. They're both headed in a straight line towards Indonesia in a very rapid pace. That all began in 1859 due to that solar storm. So clearly the sun is the mechanism to kick off these excursions. We don't know what it is. It could be a big magnetic storm like the Carrington event. Yeah. But it clearly shows that that kicked off the excursion, and it's going to continue until it reverses or calms down, which usually is poles rapidly move to the equator. Then they pop around all over the Earth for a few hundred years. Then they go back to their original position.
What does that mean, that the crust is going to shift?
That has nothing to do with the crust. Yeah.
The magnetic poles have nothing to do with the physical poles. The axis of rotation, totally different things. And we are not proponents of crustal displacement theory, because
geographically nothing will move on the planet.
No, this is only magnetics. So imagine that the Earth is a magnet, which it basically is, right? It's positive on one end and negative on the other. However, it's not quite that black and white, especially right now. So let's say when the north is strongly positively charged and the south is strongly negatively charged, that's when our magnetic field is very strong. Right now, we're in a situation, if you can imagine, kind of blobs, areas on Earth that are more positive than negative, and other areas that are more negative and positive, and like sort of moving around like a lava lamp in a way. So we have areas of positive charge that are not concentrated. And so that sort of creates this situation where the magnetic field is weak. And I think that has something to do with why the pole can maybe move more readily when we're in a state like that, if that makes sense.
So then what are your thoughts on the Earth tilting and the North Pole ending up being where just above Chile, and the South Pole where Bengal Sea? What are your thoughts on that theory?
Well, I have a copy of the Adam and Eve story, an original. It's now worth over $1,000. And when I bought it, it was worth $12. And then people started talking about it again. And within 4 months, that document that everyone claimed was recently declassified, that's all a bullshit narrative. What was declassified from the CIA was their copy of them reviewing the book, not the book. The book was always available. It was in all antique stores. You could buy it on the internet. But the CIA heard about the book. They did some research into it, and they wrote a file on it. That's what was classified, not the book. The book was available all around the world. So it's a false narrative there. Now, what's more important is the science that Leah and I discuss on the channel. There have been peer-reviewed papers. We started 6 years ago with the first one that found a 50,000-year-old frozen nematode that they reanimated in the permafrost. So that means that the Arctic has been frozen continuously for at least 50,000 years. And then last year, a paper came out where they reanimated DNA that was 2 million years old from the permafrost, which means that
I think it was 2.5 million years old.
The Arctic has been up there for 2 million years at least, because this DNA is perfectly preserved. The only way that's possible, DNA is so fragile. It does not make it 2 million years in the dirt. It has to be perfectly frozen continuously for them to find it. And if the Arctic shifted anywhere out of the Arctic Circle for a few hours, that DNA would have been destroyed in the soil. So based on what they're finding in the Arctic has always been in the Arctic for millions of years. A lot of people claim that there are animals found frozen in mucks with tropical plants in their stomachs. They're liars. All of the peer-reviewed literature, there's dozens of frozen animals perfectly preserved with plants in their mouth and stomachs. All of the plants found correspond to plants that are in the Arctic currently. People are lying. The only tropical plants ever found in the Arctic or the Antarctic are fossils that are hundreds of millions of years old. They're not recent. And so people are either lying to you on purpose or just dumb because they don't look into the science.
And the hundreds of millions of year old fossils that could be tropical this would be a function of like the Pangea, right, where all of the continents are stuck together at an equatorial area. That is a very, very, very long time ago. The continents
250 million years ago, before the Atlantic.
250 million years ago, they have obviously separated since then. So that evidence that people are citing of tropical material is from a completely different phase of Earth. And so this is the confusion. People are confusing the tropical fossils from that era, from very long ago, with a much more recent findings of, like Diamond said, plants in the mouths and stomachs of animals that are naturally found in the Arctic in the last, couple of million years.
Yeah. In fact, there's been dozens of species of perfectly preserved animals. We've got now deer, we've got a baby foal, we've got dozens of mammoths and baby mammoths, we've got steppe bison perfectly preserved. All of these animals that are all extinct because of the Younger Dryas event are perfectly preserved, and people think they're all preserved at 12,008. Not a single one of these animals has been found frozen with that date. They are dated at 40, 41,000, 45,000, 32,000, 38,000. None of them are dated to the Younger Dryas event. And people are unwilling to actually go look at the peer-reviewed literature to look at each individual specimen and see what they say. They find plants that are still on the Arctic steppe today, perfectly preserved in their mouth and their stomach. They never mention anything tropical or anything stupid, because these are actual scientists writing the papers, and they're writing on what they are observing.
But it wasn't the point that they froze very quickly. So the only way
had to perfectly preserved. So the theory is they're all found in these valleys in what are referred to as the mucks. The mucks are these huge mud debris piles where everything's mixed up. The only way you get a mixed up mud debris pile is from a catastrophic flood into a valley. And so if we're in the Arctic and everything is frozen and it's during the ice-free corridor time, let's go back to 35,000 years ago when Beringia, if you're familiar with that, sea level is down 400 feet. And the entire area from Siberia to Alaska is way above sea level. And it's a grassland. This is what all those animals are feeding on that they find in their stomachs. There's no ice there. But there's ice very nearby where these huge herds of megafauna are. And this is when the comet starts breaking up that causes the Younger Dryas event. And small pieces of it are hitting the ice sheet. And each time they hit the ice sheet, a catastrophic flood, a deluge washes, kills a few animals, and and freezes them into the valley each time. So each fragment, one hits 40,000 years ago, one hits 31,000 years ago. And they're perfectly preserving these animals that are roaming on Beringia. And so we've got this, like, it's like a book of the pre-impacts before the end of them all. And then once the 12-8 event occurs, there's no more mucks because there's no more ice. There are no more instantly frozen animals because the ice all melts and it's all over at that point. But before that, we've got geologic evidence that something is coming and hitting the ice sheet and killing a megafauna before the big event.
Okay, so then you agree with, I guess, Thomas Chen, and that the magnetic field does change over time in a cyclical pattern. The Earth
Not cyclical, though.
oh, randomly, or
Yeah.
irregular pattern. It does change, but irregularly. We cannot predict how the intervals. And then the Earth doesn't move geographically. It doesn't tilt anywhere. It just stays the way it is.
Based on all geology, yes. If the Earth were to tilt in any fashion, at any speed, like I'm saying, it could tilt a degree a day without a catastrophe, maybe. But all these catastrophic models, like the Adam and Eve story, or Hapgood or crustal slip or any of them, everything on Earth would be eliminated. There would be nothing left. There would be no complex life. There would only be a few. The only thing that would survive were algae and bacteria, because of the way that the system works. We're spinning at 1,400 miles an hour at the equator. If the Earth were to tilt a little, the centrifugal force would smash everything into the wall at high rates of speed. It just is not possible to tilt the Earth in any way catastrophically without flipping us out of our orbit, wobbling out of our orbit. It's a fairy tale that makes to scare people, but it could only happen. And we discussed this recently. If another planet were to fly by a very close proximity, just a few Earth distances away, and the magnetic fields would interact, and then they could shift. But then they would shift back after they were done interacting.
But it wouldn't be in like a sense of the axis of Earth shifting, because I mean, like Diamond said, it would be like being on a train that's going 200,000 miles an hour and then suddenly being stopped.
Or turning
left. Imagine the destruction that
you can't do that. You can't make a left turn at 200,000 miles an hour.
Yeah. Well, how about the ancient myth that talks about the sun that set the other way
we
were just talking about this on our show the other day.
So Immanuel Velikovsky, a very famous man who wrote many books, he went through all the mythology within the last few thousand years. And all of these concepts, biblical or from Velikovsky or other mythologies, are all recent, meaning in the last few thousand years, the Earth stood still. That's one of them. The sun stopped. The sun rose in the west. And so you can get all that without flipping the Earth. You just need to stop the rotation of the Earth. And the way you can do that is with another planet flying by in close proximity. So if you start to pull two bodies together, the rotations, the magnetic fields will affect each other. You could slowly stop the rotation of the Earth and actually make it spin in the opposite direction. If it was at a slow enough pace, people wouldn't notice it. And so Velikovsky explains that maybe 2,000 years or so ago, Venus flew by, Mars was closer to us. The concept is that Venus was ejected maybe from Saturn. It was Saturn's core or Jupiter's core. If it was Jupiter's core, it explains the red spot on the planet. So the idea is that we were part of a solar system that is not our solar system. We were in the Saturn solar system. So it was Saturn, Mars, Venus, and we were in a polar alignment, meaning our solar system, we're all on the equatorial plane of the sun. We were on the south pole of Saturn, all in a straight line. And these four planets moving in a straight line with their star entered our solar system and broke apart. And it's this catastrophe that's very recent that is written about in all of Velikovsky's books. And because we have mythical accounts of the earth standing still and the sun rising in the west, it very well may have happened, but no one is willing to look into it.
I think there's a lot of different ways it could happen, right? Like, the Velikovsky idea may not be correct, but, imagine our current solar system as it is, and let's say a comet gets captured by our solar system. So when that happens, given that it seems very clear to us that all of the orbits, they all have a relationship to each other. So imagine that our solar system is really like an atom, that all of the planets are the electrons that are in orbit around the nucleus. So when you shift one of those, you affect all of the other electrons. So if we captured a comet, perhaps this affects all of the orbits of the nearby planets temporarily as we adjust to a new situation. So, it might not even be like, that the Earth's rotation changes, but that our orbit change. It wouldn't be that, because that would present the same problem as the freight train that stops all of a sudden.
Right.
It would,
So
it would
the
be
most probable. Yeah, the most probable is an object perturbing our orbits and the Earth. Let's just say the Earth moves 100 miles further out in its orbit very slowly. It would appear retrograde motion. The sun may look like it's setting after it rises. It could rise for a few hours, but if the Earth is moving away, the sun would appear to set again and then rise again, and people's minds would be blown. They wouldn't understand retrograde motion.
It would be the same. It's the same concept as what we do actually observe today, retrograde motion in other planets. So as we observe other planets going around the sun, let's say, Jupiter, there are periods of time where Jupiter appears to be going backwards in its orbit, but it is literally just a matter of perspective. It's not actually going backwards. It's still traveling the same way it's been traveling. But to us, for a period of time, based on our position and its position in relation to the sun, it just appears to be moving backwards. So it could be something like that, where, another object is captured, it affects orbits of our orbit and other bodies, and creates this illusion of the sun rising in the west instead of the east for a short period of time. So it may be that something like that happened, which is probably a better explanation, because we don't have any way of explaining how, the Earth would suddenly tilt and not cause major catastrophe or change its rotation. I mean, it would be completely devastating to everything on Earth.
And there's no geologic evidence of like the oceans washing over the continents. We would have huge salt deposits. We would have these huge die-offs of forests if that happened. There's no evidence of it in the geologic record of the Earth stopping or the oceans washing over continents or any of that. Just like I said, we've got perfectly preserved DNA in the Arctic for millions of years. So the Arctic has always had to be up there. The Arctic has always been up there. So something else is going on.
So what do you think caused these, for example, the Noah's Ark event and the floods? What is causing it?
Well, we've nailed that down pretty much exactly to the date. There are huge impact structures near Australia, which correspond exactly to the flood of Noah. So no one would have seen these impactors. We're talking, I forget the size or what the name of the structures are. Do you remember? And I can't pronounce them. Remember?
I don't know. I don't remember.
I would always pronounce them wrong. These two structures are in a bay in northern Australia. I wish I brought them up.
Maybe it'll pop into my head, and maybe
they correspond to the flood of Noah. So you're going to have this like let's say a 2-mile wide asteroid hitting the ocean. It hit so hard it displaced 2,000 feet of water and hit the bottom, because the impact is that deep. So it would have sent a mile-high tsunami around the entire Atlantic rim and would have flooded all the continents. And so it is an impact that probably was. So if you're on land and you see this mile-high of water coming and you never saw the impact in the ocean, it's Noah's flood. It's a wall of water coming. And you would be able to maybe predict it if you saw the comet coming. Someone had some pre-knowledge. They might have said a catastrophe is coming. Because back then, comets were the harbingers of death. So maybe someone saw the comet coming, the comet hit, the flood of Noah, and it's a myth. And that was 5,400 years ago. This impactor is dated to, which kind of dates to the biblical time pretty accurately.
Damn,
I'm
okay,
trying to find the name of the crater, and it's funny because I'm looking at a list of impact structures in Australia, and it's not here. I still can't remember
Noah,
the name.
just put in Noah comet. There's an article about it. Noah comet impact. Yeah, so so also our show has focused on these catastrophes, which are the unknown impactors. You know, when we started the show, we thought they happened every few thousand years. The more we looked into it, things hit our oceans on a very regular basis. At any time, almost everyone living on the Atlantic seaboard could die in an instant. Because if an object big enough hit the center of the Atlantic, the propagation of the tsunami would be 5-6 hours to hit all coastal cities. There would be no way to get anyone out of those cities. Everyone would die. And we don't have a warning system, none of that. So it's funny that there are so many catastrophes about to happen, not to mention a VEI-7 eruption. We haven't had one for a few hundred years, but they happen every 100 years. And that would literally kill 80% of the population on Earth. The sky would go dark.
Can you tell what is that?
It's a scale of eruption. So the last VEI-6
volcanic eruption
is a volcanic eruption is Mount Pinatubo. It cooled the Earth at 1.1 degree. A VEI-7 would cool the Earth 3 degrees, darken the skies for years, and kill 80% of the Earth's population. And that's going to happen. That will happen in the future. It's not a question of if, it's just when is the next one.
The VEI scale, to some degree, determines how high the particulates from a volcano reach. So when those particulates,
but more importantly, the volume of particulates
and the volume, yeah. So when we have particulates reaching the stratosphere, and a lot of it, things tend to stay in the stratosphere for a really long time, and so then we end up with actual cooling of the Earth, which, especially with the way that we live today in modern society, where we have these big monoculture, mono-agricultural operations, that you can't just pick up and move easily in response to changes in climate, means starvation for a lot of people. And
there's just not enough light reaching the ground to grow anything.
Right.
Everything's diseased and it's bad. So the
last
time this happened was recently. We had a recent event like this, 536 AD. It's called the worst year to be alive. People talk about it. Not only did we have multiple VEI-6 and maybe 7 eruptions happening worldwide, one in Iceland, one in the Philippines, but we also had a comet impact the ocean, a 3-banger. And so we've got the comet sent up moisture into the atmosphere. We've got particulates in the atmosphere. You mix particulates and moisture and you get flooding rains. Everyone's heard of the mud floods. The mud floods occurred 536, 537, 538 AD. They buried Rome. They buried all these ancient cities in tens of feet of mud. And they happened because of catastrophic volcanic events and lots of moisture going into the atmosphere. You might have recently noticed in the last 3 years, this epic 500-year catastrophic flooding worldwide. That's not an accident. It's because of the Hunga Tonga eruption in 2021. That increased stratospheric moisture 10 to 14%, and it's still up there. It's still coming down. So it's not a mystery. It's not cow farts that are creating floods. It's a volcano, and the temperature on Earth is controlled by the sun. And, everything has a very concrete explanation if you look into it.
So I'm assuming the cosmic, the comets and so on hitting the Earth is because of the magnetic field weakening. That somehow
maybe. So there might be a connection. That's that needs to be looked into. Like, as if the field weakens, we become like an actual magnet sucking these things in. It might be. It also might be something is happening with the outer planets. Our sun is magnetically connected to each and every planet through a Birkeland current, which goes through the poles. It's why we've got aurora on Jupiter and aurora on Earth. These electromagnetic plugs or Birkeland currents are going into the poles and supplying it with energy. So the idea is that Jupiter is gigantic. It's way out there. And it has a huge magnetic field. We're talking the Earth is, would be like a tiny little magnet compared to one that's thousands of miles wide. Jupiter is huge. Its magnetic field is insane. And it's able to bring things in where these asteroids are in the Kuiper belt or in the, we just found a planet outside of Pluto that has like a 25,000 year orbit, which may have something to do with our 26,000 year cycle. We just found that. It is planet 9. No one wants to talk about it because Jupiter's not, or Pluto's not a planet anymore. So this one is not a planet anymore. And so we've got all these big objects outside of Jupiter. Something might happen to Jupiter to turn it on to draw these objects in. And once they get past Jupiter, guess where they're headed? To the sun. They're going to head to the sun. And guess what's between Jupiter and the sun? Earth. And so that might explain everything.
What do you think about the fact that we are seeing more auroras now and closer to the equator?
It has everything to do with the weakened magnetic field. So what Diamond was explaining sort of about all of this energy coming into the poles, and then we have this weakened magnetic field. That is literally what allows us to see aurora at lower latitude. And these days, one of the things that we've noticed is when there's, even a minor shift or event with the sun, our magnetic field seems to be very sensitive right now. We seem to be seeing the effects in a much more dramatic way than we have in the past. Like geomagnetic storms seem to be triggered more easily, and they're stronger for certain events than we've seen in the past. And that is, again, all a function of a weakened magnetic field. The magnetic field at the poles is naturally weaker than what you find at the equator. So that's why you typically find aurora at the poles. But now that the whole field is weakening, we see them at lower latitude.
So then the Earth is not shifting or tilting. That's good news. But what should we expect, do you think? Do you have any speculations what can happen in the next decade or so?
Well, the bad news is the correlation between cosmic rays and explosive volcanic activity. A paper coming out around 8 years ago determined that muons in the subsurface. So cosmic rays, if you don't know, they pass through humans, and that's what causes them to mutate cells. They go right through you. If they hit the cell at the right spot, they'll mutate it. And then they go through the entire Earth, right? They keep going. Nothing stops them. We have very little shielding for cosmic rays. But what they found was cosmic rays heat silica magma. These are the ones that are VEI-7 eruptions. The big explosive volcanoes get heated by cosmic rays from space. So there is a correlation with solar minimums and grand solar minimums and large eruptions. And because what's happening is as the magnetic field weakens, more cosmic rays bombard the Earth and heat up these magma chambers. And that is when we get super volcanic activity. Super volcanoes, Campi Flegrei, Yellowstone, the big ones that darken the skies for years and kill everyone occur during magnetic excursions. So that is one of the consequences. The temperature doesn't change, but if a volcano big enough goes off, it will change the climate for a decade, and then everyone else dies because of that. So cosmic rays heating magma chambers, causing major volcanic eruptions. That is the biggest threat. The second one is the biosphere, increased UVA, UVB, and UVC reaching the surface. It's bad for plant life. It's bad for humans. It's bad for all animals. They get cancers and die. And so, yes, if the magnetosphere continues to weaken rapidly, people that work outside will get skin cancers. Animals will get cancers. Certain plant species won't be able to be produced with certain levels of radiation. Now, you could just grow in rigid greenhouses with the right film because like we have Solex, it protects from all harmful radiation, right? All glass in homes now have to be protecting from UV. They call it like eco glass or whatever they call it. So if you could just stay inside during the day and go out at night, it's going to be very dangerous to go outside when the sun is up at the bottom of the magnetic excursion.
But the big question is going to be, when does that magnetic excursion actually happen? And I don't know that we really have a good handle on that. I don't know that it's that clear how quickly the field is weakening and when we reach that point. I don't think it's not in the next decade, I don't think.
Well, it is accelerating. And if you use a log acceleration of the reduction in the magnetic field, we could have the low point as early as 2035 to 2045, which is in a little more than a decade. If you could bring up the last visual I showed was the magnetic field strength one. You can actually see where we are on the graph there. On the left side here at 0, you see it began dropping down about, let's say, 1,500 years ago at the peak. You see that black part of the graph?
Mm-hmm.
And we are actually down below 5. You see where 5 is on the graph?
Oh,
and so that's as low as what they called an excursion in the Younger Dryas. We are down near VADM of 5. I think the last reading was around 6, which is, one of the weakest magnetic excursions on the graph. We are nowhere approaching Lechamp, which is down at VADM of 1.5. So I think when we hit a VADM of 4 or lower, things will be very bad on Earth. And that could be as early as a decade from now.
So very bad means comets hitting, volcano eruptions. So comets, and then the floods, volcanoes. What else?
And then the radiation in general.
The radiation.
Yeah, radiation exposure that would be a huge impact on all life on Earth.
That also explains the Göbekli Tepe, I think, right? Because we initially, I thought that maybe because of flood, but also maybe because of the cosmic radiation, they were living in these structures, the Göbekli Tepe structure in Turkey, for example.
Yeah, and there's a mythology of small people on the eastern seaboard that only farmed at night. They came out, they only did everything at night. They were called the Moon-Eyed people. These are people that might have been around during one of the excursions, like at 12/8, and they found out that they are very pale skin. They found out that their people that went out during the day were dying, and they're like, we can't do this anymore. And so their whole society changed to doing everything at night. As the sun set, they came out.
Do you think that also maybe explains how we had this like introduction of like white genes, I think 3 DNA, that we became whiter? It could.
I think that has to do with a subset of humans moving into caves for a long period of time. You lose all the need for melanin. Melanin is very important. It's specifically important for these events. And one of the ideas in some of the papers that come out on why Neanderthals went extinct, most of them say, well, Neanderthals lived out in the plains and they lived far from caves. And the Cro-Magnons lived in cave shelters and rock shelters. And so they were already predisposed to be safe. And the Cro-Magnon never got the memo to join Homo sapiens in caves. The problem with that is a new paper coming out showed that Neanderthals and Homo sapiens were living for thousands of years together in the same cave and teaching each other stuff. So that's not what happened. What might have happened is that Neanderthals might not have had the right melanin needed to protect them. And so no matter what they did, the radiation got them. Yeah. And it's because we can sunburn and we can tan that we made it, because we have that melanin. But the reason we became white was for a long period of living in caves, perhaps.
I mean, it's interesting too, because, and this is something else we've talked a lot about, at one time we had all of these different hominids on Earth, and we're the only ones left now, and two points that I want to make. What Diamond was talking about is the little people who were farming at night. I really think that we have to pay more attention to what is spoken about in mythologies, because I don't think that that's all a function of humans just making things up. I think that they're probably based on something in reality. And this kind of makes sense if you consider like the hominid, for example, Homo floresiensis, which was a very small human. And my theory is that, we know that we interbred with the Neanderthals because it's in our DNA. We know that to some degree, in some parts of the world, we interbred with the Denisovans because it's in the DNA. And there's other mysteries like there's the out of Africa hypothesis that we all came out of Africa. Well, part of the problem with that is that if you look at modern African populations today, there is a what's called a ghost DNA in their genes that other humans don't have. So that means that we didn't all come out of Africa. That we're probably a mixture of hominids. And my theory is that when times are good, when the climate is warm and things are relatively stable on Earth, and it's easy for us to travel around the globe, that we probably interact with other hominids and maybe we're able to interbreed with them. And then when catastrophes happen, it causes us all to be in isolation. So we all go into our little pockets. And when that happens, we start developing different physical characteristics. This is not really that different than the way that we breed dogs or cats, for a specific species. It's kind of what we're doing. We're sort of selectively breeding ourselves, not intentionally, just based on the physical conditions.
Well, I would also say, moreover, that genetics are one thing, but what we really don't know is anything. Science is so limited. We base all of our paleontology on morphology. So we're saying one species is different than another species because it looks differently. They don't have any genetics based on this. It's just based on the conclusion it looks different. So if we were all to die today, the whole globe were to die, and we're all going to get buried in 10 foot of dirt, and a group of aliens came that are paleontologists and started looking at the skeletons, they would find a Samoan skeleton and name it a species. They would find an Asian skeleton and name it a different species. They would find an Inuit Eskimo skeleton and name that a different species because the morphology is completely different. They'd find an African skull from Central Africa with a brow ridge, and that would be a completely different species. When we're all Homo sapiens sapien, they wouldn't know unless they did the genetics that were all the same. And I think a lot of these hominids are mislabeled as different groups when they're actually just us.
Which probably would help explain why we were able to interbreed, right? Science holds that species are distinguished by their ability to breed or not breed with each other. However, we have apparently been interbreeding with other hominids, which goes against that idea. So I agree with Diamond. I think we probably were all the same species with dramatically different physical characteristics. And we know this can happen because we see it again in dogs. We have, whole species of dogs, and then all of these breeds that look wildly different from each other. And again, as Diamond was saying, it's the same with them. If all of the dogs died and, some other civilization a million years from now, looked at the bone structure of all of the different dog breeds, they would probably conclude those were all different species of animal because they look so different from each other, but they're not.
Right. So no paleontologist would put a dachshund and a pit bull in the same species if you looked at the skeleton. You'd be like, these are completely different animals. I mean, this one can bite a brick in half and this one can barely walk. They would not consider them the same dog. And then put the mastiff in there. That's like a horse compared to a dachshund. So there's a lot of problems. Like I explain all the time, like geology is brand new. It's only been around for a few hundred years. We don't know anything. We haven't even looked in the bottom of 98% of the ocean floor, which is on Earth. And we're going to go to Mars and build a colony. Get out of town.
Wow.
There are so many cosmic rays on Mars. That's a whole nother podcast. Elon, I hate to break it to you. There are no humans going to be living on Mars ever.
Yeah. Okay. So I just realized that you said that the core heats as well, right? Which causes the volcanoes. But in Thomas Chan's book, one of the reasons why he thinks there's going to be a tilt is because of that heat. Actually, this jelly thing between the crust and the core.
Right. So the idea is there's some kind of a magnetic connection between the crust and the mantle. And in geology, we call it the Mohorovic discontinuity. It's the liquid plastic zone, that all the crust is, the only reason we have plate tectonics is because the crust is floating on the earth, right? And so the idea is that something happens where this decouples and the crust slides.
So it
The
becomes
problem with
liquid.
that is the geologic evidence doesn't support it. We've got perfectly preserved DNA in the Arctic, which means the Arctic has been in the Arctic for millions of years. So that's the problem with that idea.
Well, and there's another problem too, which is, you know, the Earth isn't a perfect sphere. You know, it's more sort of obloid. And so if you have a crust that's sort of all together and it all shifts together, it's not going to slide very readily because of the shape, because it's not a perfect sphere. You're going to run into a lot of resistance.
There would be a lot of cracking of the crust.
Yeah.
Okay.
Yeah.
So I mean, I think the evidence of, you know, of DNA that's been frozen for 2.5 million years in the Arctic is, to me, is the best reason to reject that idea.
Plus, geologically speaking, and we talked about this in a show, if you research all peer-reviewed literature, the earliest any part of the Arctic has been warm or tropical is 50 million years ago. And for the Antarctic, it's almost like 90 million years ago. So that is a very long time that those places have been in those places.
Which again, you know, the fact that those areas could have been tropical, let's say 90 million years ago, would be a function of all of the continents being together, stuck together.
They were all together 250 million. They began breaking up. Antarctica started sliding down to the South Pole first, which is why it's that old. It's been down there about 90 million years in its current space. It took a little further for the North Pole, the Greenland to move up there and everything. So it was 50 million years ago that finally left the subtropical zone. So that just shows you how slow plates move. It's been 50 million years and we're all pretty much in the same spot.
What if the theory that it just tilts and then goes quickly back up, which causes
that could be, but the only way that would make sense if it happened so rapidly that nothing could melt in the Arctic, right? So it'd have to be like within a day, because we need to perfectly preserve the permafrost has to be frozen for 2 million years continuously to find DNA. So it would have to happen for 5 seconds, in which case everything on Earth would die if you were to tilt the Earth that quickly.
Okay.
I mean,
is it possible that that North Pole moves to let's say where Bengal Sea is now, but then because it's already a North Pole now, it doesn't necessarily have the time to melt, but stays frozen because it shifts, and then now
there is evidence. Mauriello build reps used AI and Google to calculate all the megalithic structures on Earth to former pole positions. Are you familiar with Mauriello?
I'm going to talk to him soon as well.
Yeah, he's a friend of ours, so tell him we said hi. So, and he very compelling evidence. You know, he doesn't have any agendas, and it shows 3 or 4 former pole positions that are moving through Greenland. I like that possibility. So what it would show, and I think that you could refer to this as true polar wander, is that something is happening during these events that is causing the Earth to slowly tilt. And it would be every 100,000 years, it moves 10 miles, you know? And so each time the rotational pole is so slowly sliding. That could be what's going on. Not the quick tilt, a slow movement, but it might not be the crust slipping. See, it might be the Earth expanding, because I don't believe in plate tectonics, because the oldest ocean crust we have geologic evidence for is just a few 100 million years, when we have crust that's billions of years old.
Yeah.
Billions of years old. We have 4 billion year old crust, but we don't have any ocean floor that's older than 250 million. So there is a problem. That means the oceans are new. And so modern geology says, oh no, all the ocean floor has been subducted. And you're like, no, because if we shrink the Earth back 200 million years ago to no ocean, right? Because there's only 200 million years of ocean. It's a smaller Earth. And that's when we have dinosaurs. and the Earth has to be half the size to get half the gravity for them to live. So it has to be that. It's almost so obvious. Again, it's going to take 50 years before anyone gets that memo.
And
It's still
Mario,
sorry,
Mario, sorry,
right?
go ahead. I apologize.
Sorry, just to make sure that you mean the expansion, the Earth expands in size. Okay.
Yes.
Yeah,
And
the expansion
Mario,
is looking like the North Pole's moving.
Mario has a great sort of metaphor for sort of how this is happening. And it says, so he says, imagine you have like an orange peel that is cut from the north down to the south. So you have these like sections of orange peel, because especially his data would suggest that we're sort of expanding more at the South Pole first than the North Pole. And his data actually shows, based on the movement, kind of shows that this is likely the case. It's not an even expansion that's coming directly from the center. It's more coming from the southern pole.
The South Antarctica is surrounded by a mid-ocean ridge. There is no explanation for that except for the Earth is expanding, because there's no subduction going on down there. So what's happening is that the South is expanding out, and the whole globe is moving with it. And so it might be slightly differential. If it's happening more just a little on one spot, it would cause the position of the axis of rotation to be rolling, which would give you new pole positions as we, asymmetrically expand.
I mean, there's other things that point to this. For example, like we can measure, we have ridges where expansion of the ocean floor actually occurs, and we have this mapped out. This is sort of how we know how old the ocean floor is in certain places. And incidentally, that's somewhat measured based on magnetic field. There's a record of the magnetic field in the ocean floor. Diamond, can you remind me what particle it is that sort of records the magnetic field?
Well, anything that's magnetic.
Okay, yeah. So anything in the
basalt is ferrous. It's got iron in it. Basalt is low silica. The sea floor is made of basalt. And so literally, as the magma is coming up, as soon as it cools, mid-ocean ridges look like this, conveyor belts. So as soon as that new magma cools, it locks in the magnetic field of Earth at that moment. And it keeps a continuous record of the magnetic field as the seafloor is spreading.
So in other words, every molecule of the lava, itself has a pole. It has a north and a north pole and a south pole. It has a positive charge and a negative charge. It has polarity. So like he said, as soon as it cools, it locks that into place. And so that gives us essentially a record in time. So we have these ridges that we know are expanding because we can record that and follow it. And then we do also have subduction zones where parts of the floor is going underneath other parts. The problem is that there's more expansion happening than there is subduction. And the Pacific Ocean, for example, the whole Pacific Ocean is still expanding in size. Now, proponents of plate tectonics will tell you, like Diamond said earlier, that there's just as much subduction as there is expansion, but that's not true. And again, the Pacific Ocean is still expanding in size. So it would suggest that we are expanding. We don't know if expansion is happening on at a consistent pace at a slow level, or if it's happening in spurts. But this, some of the ideas in this may help explain some of the catastrophes as well. But it also, I think, provides something really important. Like I keep mentioning Pangea, when all of the continents were together. The problem with that is that if we have Pangea, where all of the continental crust is all together on one side of the Earth and the whole rest of the Earth is ocean, you end up with this like very lopsided spinning structure that can't be stable in a physical sense. So if all of the continents were once together simply because the Earth was so much smaller, then it makes sense. Then we can make sense of the physics. And that we've slowly expanded from there with the creation of ocean floor.
Yeah, Luisa, let me blow your mind. My field of study is stratigraphy and paleontology. So I look at the rock record. I was a field geologist. I looked at it in hundreds of thousands of places worldwide. I was out there. Here's the funny thing. We have ocean deposits 250 million years ago and recent. Prior to that, all of the ocean record we have, all of the oceans were on continents. We called them continental oceans. Let that sink in.
It's the reason why you
350
find
million
like
years
shells
ago,
up on mountains and stuff.
350 million years ago, all the oceans on Earth were continental. They were inland. They were on the crust, not on the seafloor. Why is that? It's because there was no ocean. The continents were flooded because that's where the ocean was.
People ask this question all the time. They say, why do I find seashells, you know, like up on a mountain? Like, okay, we live up at 7,000 feet. We find little shells up high. And the reason is because millions and millions and millions of years ago, there were oceans there.
All of the
land,
oceans,
inland.
all of the oceans were on continents. They were called
And
continental
then
oceans.
the Earth expanded, and that's how we have ocean beds.
And that's why
all
none of
this,
the ocean.
and that's why the continents are all dry. All of the seawater ran into the ocean.
Oh, okay.
The continental crust is 4.5 billion years old. And the ocean floor, there's no part of the ocean floor that is older than 200 million years.
No, it goes, it goes to 280.
Okay, 280 million years. That's quite different than 4.5 billion
And the
years.
Atlantic is brand new. The Atlantic just began opening 220 million years ago. It was never existed. First, it was a crack. Then all of the inland seawater flowed into this hole, which was called the Rift Valley Lake, and it kept spreading. And then it became the Atlantic Ocean. So geology is new. Science is new. People claim they know stuff, but when you start looking into it, we don't know nothing. And it's going to, we won't, you know, it'll be 50 years from now that mainstream science will be discussing the things we're talking about here today.
Okay, so now let's talk about the what do you think about the next Carrington type of event? Do you think it can happen soon?
It can
And
happen
what
whenever it wants.
Yeah.
And what would be the implications, do you think?
Devastation to the human civilization. I mean, we are living in an era where we are completely dependent upon electricity and technology. You know, the Carrington event set the telegraph lines on fire. The only reason the impacts weren't bigger was simply because we didn't have an electrical grid everywhere. If we have a Carrington size event today, it will fry our electrical grids, and that will completely and utterly disrupt civilization. It would take so long to come back from that.
Right. Major solar storms are an issue, but they have to be huge. The Carrington event, we're talking X30 is the lower threshold for any effects. It would have to be a very huge series of X flares in the X40, X50 range, which is very rare. We've had some X30s and 40s in the past, but they were during solar max in the 80s, and our magnetosphere was very strong. Now that it's weakening, we are more and more vulnerable. So solar storms are a problem, but there is a new player in the game called the Miyake event. And this has only come to light in the last 10 or 15 years using dendrochronology, which is tree rings. And they've been studying carbon-14 deposits in tree rings, and they have found at least, but not limited to, 10 of these solar proton events that are 1,000 times stronger than the Carrington event. And they've happened all within the last 14,000 years. What they are, no one knows. But if a Miyake event occurs, no one knows what that would be. That would be Carrington times 1,000. Now, several of these have happened while we've been on Earth. The most recent is the Charlemagne event in 774 AD. And it didn't kill anybody that we're aware of, nor did it cause auroras, because it's not in the historical record, but it's in the tree rings that carbon-14 and other cosmogenic elements spiked for almost 2 years. Remember, we talked about these? These are solar storms that last for years, not 3 days. Can you imagine the May Mother's Day solar storm lasting for 2 years? So that kind of event is definitely going to end humanity in the sense of modern technological humanity. We get kicked to the Stone Age in an instant. And there's no way to just like fix the fuse or rebuild the infrastructure. It's a complete rebuilding of everything.
Yeah.
And hopefully we won't do it the same way, right?
We literally live our lives, you know, in anticipation of something like that happening. Like, we fully expect that at some point we will be living like it's the 18th century, and we're planning on that. You know, we grow lots of our own food, and we have lots of supplies, and we're sort of prepared for whatever the case may be. But it would be just a disaster for humanity as we're living today, because we would have tons of people who are, you know, are dependent on a global food supply that would no longer be available to them, because the electricity and fuel and all of the pumps and all of the things that go into our civilization would no longer be functioning. And there's just no way to come back from that in any quick fashion.
This is the first time in history that humanity is not self-sufficient. It's happened in just the last 100 years. No one knows how to grow food. No one knows how to go fish and hunt and wild harvest 100 years ago. And then for the rest of all of humanity, humans were self-sufficient. And whatever this control mechanism is teaching us to rely on them is the downfall of our species. We are going to be wiped out in an instant while people stare into little squares that aren't doing anything, saying, "Oh, I need food." I mean, it is going to be embarrassing. And you should be as far away from people as possible when any of these events occur, because you don't want to be there.
Right. So we hear now some government officials saying in different interviews, hinting that something like that can happen, that what we might lose everything, our comfort soon. We have all these, the riches trying to build all sorts of bunkers. So, but as a normal average person, where do you begin? What do you do? How do you personally, what are you doing personally?
Gosh, this is something that we've talked a lot about over the years. And number one, I'll say I highly recommend, and I'm not going to remember her name right now, Diamond, who is our friend that we've interviewed several times.
Anita Bailey.
Thank you. Anita Bailey, who wrote a book called Cold Times. And this is sort of in from the perspective of going into grand solar minimum, where it would actually be colder. But the advice in this book is really relevant to any situation in that, you know, where we don't have electricity and stuff like that. So I highly, highly recommend that people read that book, because she kind of covers all of the bases of what someone would need to do to be able to survive that. You know, for us, you know, our focus is really on being as self-sufficient as possible. You know, we live in a very rural place, like we are far away from all major cities. You know, we have a small town that's 15 miles away, but, you know, we live out of town, you know, and that's for a reason. We grow a lot of our own food. We raise our own animals. You know, we continue to sort of build our homestead here. We do have plans to install solar at some point so that we can unhook from the grid. That doesn't mean that we will have solar electricity forever, or, you know, because we could have a really good hailstorm and wipe out our solar panels, and that's the end of it. Or let's say we have a solar system set up that's not well protected, and then we have a Carrington type event. Well, that's the end of the solar system. I mean, so we also expect at some point that we just may not have electricity, period. And we will just, like I said, live like it's the 18th century.
Anita always said the best way to prepare is to go to your circuit breaker, turn off the power to your house, and leave it off for a week.
And see how you do.
What happens. So you first have to eat all the food in your fridge or cook it. And then you got to live on what you have for 1 week and no power. And then you'll start to realize all of the things that you never thought about. Like, oh my God, all my food's going to go bad in all my refrigerators. What do I do? You got to cook it all now, or dehydrate it, or put it in the sun, or because it's all going to be bad. That's what's going to happen during one of these events. People are just not going to know what to do. When if they did, they would be able to survive. If you have enough food to live for a year on hand, dry goods, that'll give you an edge. That will give you the buffer you need to learn how to maybe wild harvest or wildcraft or catch a fish or set up a net or do anything. So, but you have to do something. And a lot of preparedness channels say one day at a time, one thing at a time. That's all you got to do. Learn one thing every day, because there's no way you'll know everything or have everything set up. And just like Leah says, we don't really want solar or backup generators. Those are crutches. They're only, we got a generator, we're going to run out of gas. Well, what happens when you run out of gas?
And you're done.
Yeah. I mean, we never needed any of this in the past and we were fine. So
yeah. I mean, we do stockpile supplies. That includes like, medical supplies and various kinds of things we would need, a certain amount of like canned food and dried goods, but you can't stockpile everything that you would ever need. So my theory is now that you collect enough of a particular thing that buys you enough time to figure out how you're going to accommodate that need in the future. So like my let's say the canned food that I have that is not food that we're currently growing, the 1 year supply of that particular item is just there. So we have enough time to figure out how we're going to fulfill that need going forward without relying on a supply.
Right.
I think that's just sort of touching the edge of preparedness, but because there's a lot to think about in there. And it takes time. We've been building this homestead for a decade, and we're not done and we're not entirely ready. I mean, we can get by and we can manage, but we're not fully there yet. For example, we plan on raising sheep that will give us a supply of wool and meat and milk, a triple purpose sheep. Well, we don't have those sheep right now because we're very busy and we've got a lot of things going on and we can only do so many things at once. So I say in that respect, we're not fully prepared, but we have enough going on that we can definitely make it through whatever.
Are you thinking about how far away you are from large bodies of water, like oceans or seas?
Not so much oceans, but you're the geologist. You answer this.
Yeah, well, I just did a geophysical research on the continent we live on and found the safest place. There are no tornadoes here. There are no hurricanes. There's no large hail. There are no earthquakes, no nearby volcanoes. Even if Yellowstone were to erupt in a super volcanic way, we would only get 15 centimeters of ash. We're at high elevation. So if there is any major tsunami run-in from an impact, I mean, if an impact was big enough, a tsunami run-in could be hundreds of miles from the coast. We're nowhere near the coast. So we're in one of the safest geophysical weather areas on Earth. And in ice ages, this area where we live, right off of the Rocky Mountains, gets warmer and wetter. So if anything were to make the Earth colder, it'll get warmer and wetter here. The last grand solar minimum, the mini ice age, just 10 miles off of the Rocky Mountains, it was wet and wonderful. And it was horrible everywhere else. So it was a decision based on historical data and geophysical data.
We moved here from the East Coast, and Diamond, with his background knowledge of what has happened geologically in the past, helped us pick this area as one of the safest locations.
So away from volcanoes, away from water, and elevation.
And fault lines.
And fault lines, yeah.
Yeah.
We live nowhere near a fault line, which is nice.
And we also have the deepest hot spring on Earth, just 15 miles away.
Which is just a nice plus.
And it's a remnant from the largest volcanic eruption ever recorded on Earth, which is also nearby. La Garita.
But it's a long dormant volcano.
Yep.
Well, there's no way that we can probably get there. But do you know anything about Europe? What happens to Europe?
Diamond?
During any event, the population density is so high there, it'd be a nightmare in most cities. I mean, Jesus, I've been all over Spain. There are rural regions in many countries, And so if you're in an area and you have a good group of people and you're safe, you'll be fine. But during this event, whoever makes it is going to go out and be looking for supplies, especially those that are not, and there are going to be a lot of evil, bad actors, as well as, desperate people. So you're going to need really good security. I mean, it is, just watch Mad Max a few times and you'll start to get the idea of how things will evolve.
Well,
Right.
and Europe too, during ice ages, does, suffer from being under ice. So there's that.
Well, what also can happen during this is you can shut down these ocean currents. So if the Gulf Stream and a lot of during the larger scale cycles, the ocean currents get shut down. And so also during magnetic excursions, you change all the weather patterns. The reason we've got the jet stream and the perfect flow from west to east of weather is because of the strong magnetic field and all the epicycles, which control the patterns. Once the poles start to make their way towards the equator and start popping up everywhere else during a weak field, those patterns go away. You're going to have areas that used to rain that'll be deserts. Deserts will be oceans. It will be a complete reworking of weather on Earth. And at the bottom, at glacial maximums, like 26, 30,000 years ago, there's no weather. It ceases to exist. All of the moisture is locked up in the ice, and the dust profile goes insane. All you have is dust storms. There's no more rain. The only place you can live is on the glacial margin where the water is coming out or where you can get the water, because there's no rain at glacial maximum. It has all been sucked out of the water cycle. It's insane.
Are you also like sort of building like a basement situation because of the cosmic rays?
We're not really. I mean, something we've talked about that
we wouldn't ever admit it anyway.
Well, that's another thing too. Yeah, we do have some secrets that we don't talk about.
Do we need a cave? Do we need to be
right
under the, yeah.
I don't think so. I think just practically what we talked about. Cosmic rays are going to be coming from the sun. Solar cosmic radiation is what we have to worry about. There are also other cosmic rays from space, but if we can manage our time in a different way and stay out of the sun, so I think in a human lifetime,
shelter roof works. It doesn't have to be underground.
Underground's not going to give you much more protection, in my opinion. They're going to go through the rock. Cosmic rays go through rocks. They go through the earth. So water is a protector of cosmic rays. Don't do so good in thick columns of water. So if we could all live under the ocean, thousands of feet down, it might be good. Right. So maybe that's where the future of humanity is, like underwater.
Okay. Well, wow. Thank you so much. Sorry for taking so much of your time because it was so interesting. I think like I could listen to you guys talk for hours and hours. Amazing. Thank you so much.
We do have a great channel. We have a great channel called Magnetic Reversal News you can check out.
Okay. So is that your podcast, right?
Yeah, largely we do a Saturday show together that appears on Magnetic Reversal News on Rumble. Right now, only on Rumble is the premiere.
But
on
why?
Saturday nights.
Does YouTube censor it?
Well, it's kind of a long story, but yeah, the Magnetic Reversal News on YouTube got demonetized a while back. It has recently been remonetized, but we moved. We started focusing more on the Magnetic Reversal News channel on Rumble because of that. And now we're trying to get more and more people over to Rumble simply because the censorship on YouTube is so terrible.
Yeah, so and the shadow banning. Once you say one thing they flag you for, you're not going to get any more subscribers. They come. I was getting 1,000 subscribers a month. Then my second year, 2,000 subscribers a month. And then I started focusing on climate, and then I was getting 0. I got 3 subscribers for 5 years. I mean, it's so obvious. We were like one of the most popular channels on YouTube, and then they just turn it off.
Yeah. Yep. So anyway, that show was Saturday nights at 8 o'clock Mountain Time on Rumble. And then it does go up on YouTube later in the week.
Wait, sorry, one last question. Why do you think that? Because, okay, so I understand when they censor like vaccine, okay, it's malicious thing.
That's why they took down
I get
our channel.
I get it. But why magnetic pulse? Why do they censor it? What's the point?
We were actually 4 years ago discussing about the lab leak theory. I interviewed the first guy ever to claim it was a bioweapon. They hit me on that. They turned the channel off for 3 months when we talked about that. But I had about 8 or 10 videos from 4 years ago where we explain this is not zoonotic. It's somebody, this is inserted. This was created. And they didn't like what we had to say. And even though they took down and those videos, they were still in the library. And because we accumulated maybe 14 takedowns, 4 years later, they said, nah, we'll just shut them down. And so I have to erase all the COVID discussions. Then they remonetized us.
Okay. And then I'm sure also it doesn't help that we talk about the climate change hoax quite often, and it does filter into our conversation on a regular basis. So that doesn't help. Yeah.